Hey there, welcome back to the channel. We are going to start again with a new series, which is we are going to make an SPSC queue, single producer, single consumer queue. What it is, I don't have a quite understanding, but the basic understanding that I have is there is a single producer that is adding elements to the queue, and there's a single consumer that is taking it, like popping it. So yeah, that's the knowledge that I have. I don't know how to implement it. And we are going to benchmark it against what are the libraries? The Folly library of Facebook, or Meta, I should say. And what's the second one? It's Boost, yeah, and the Boost library. So we are going to benchmark it against that. And so first of all, for the first day, since it's after a long time, just want to let you know that in this series, I don't use any kind of LLMs, and I'm not going to. Only and only if, let's say I'm stuck on something and I don't quite understand that. I'm going to use LLM only when I'm stuck on something for more than a day. Okay, so if I'm trying to understand a single thing, whether if I'm stuck on a bug or maybe some kind of topic that I don't quite understand, if I'm stuck on it for an entire video, that's when I'm going to use uh, an LLM to understand it easily. Okay, so let's just get started. Long time no see, but we are just going to get right into it. So what I have a basic understanding of single producer, single consumer queues is that so uh yeah, let's make it on desktop. So what should we name it? Hmm, blazingly fast queue. Yep. Oh, I wanted to make a directory. Yes. Blazingly fast queue. Inside that we will make main.cp. No, just the basic stuff. So let's say uh, so let's benchmark this. Not benchmark this, but okay. So what I want to understand is, let's say I have this team. Okay, so let's first write, documents that people do, right? So okay, let's say I'm here and then I created documents, not documents. What do we call it? There's a word for it. Design. Let's call it design. So the design will be BFQ. So anyone will be able to like uh, create a BFQ object, which can be of type int or int pointer or whatever custom object, right? Whatever. And they will be able to run the operations push, pop, front, number of elements, so size, and I guess that is it. What are the stuff present for StudiQ? StudiQ, CPP, CPP, oh, no, this site CV reference.com. So, okay. Hello, hello. Recording. Am I audible? Audible. Yep. Good. So, okay. So, what stuff does StudiQ, like, what are the member functions of StudiQ? So, there is push in place. Oh, yeah, right. In place. I'll also need in place. Push. Let's increase right here. So basically all of these things. Replace, push, read. What is this? I've never used this. Inserts a range of elements at the end. Oh, okay. Okay, well, yeah, not going to make this. Yeah, done. Empty, yeah, okay. Empty, front, back. Access the first element, access the last element. Yeah, okay, fine. Front, back, front, back. Swap, swaps the contents. Swap is present for all the elements, right? Okay. Empty, yeah, empty check. Empty. So, okay. So these are the functions, and I guess that is it. So these will be our member functions. So how will this look like? So let's say I have main.cpp, or I should call it, uh, I call it, sorry, yeah, I call it vfq.h. Yeah, okay. So I do not want that. Oh, why did I vfq.h? Yep, looks good. So vfq. So what will it have? It will be a single import, right? And not int, but okay. So type name, no, it's template, right? Yeah, template, type name T. Is that? Oh, okay. I forgot how is it done? Okay, okay. I'm going to pass. Seated blazing. No. Okay, so I'm going to try something. Int name, yeah, template, type name T, struct. What should I say? Class. It can be a normal function too, right? Yeah, okay. So void something takes a type T and then it does nothing. Right? Something and X not good. List initialization for ultimate safety and not this. Yeah, okay. So this should work. There is no specific reason that I do 70. It's just something that I just do. I should have switched secret to 23. Yeah, okay. And what was it? Main.cp, right? It's not an unqualified ID. User can declare identify something. Uh, Something. This is how it's done, right? Template type name. Oh, type name. Something's in. Oh man, how do we do this? Template, is it like this? Yeah, okay. Yep, it's like that. Okay. This is a really bad starting. 9 minutes in and I'm already messing up bad. Okay, no problem. Because I've never like I have learned about templates, I've read about them, but I've never used them, you know. Like I've made some basic stuff with it, but that too a few weeks ago, you know. But yeah, let's keep moving forward. So we have this. This is what I wanted. Yeah. And then, so we have list visualization. No, sorry, what was I saying? Yeah. So if I have a PFQ, sorry, so a BFQ, and then uh, people can create this object, right? So they can initialize this. Let's do a default constructor. Is this how we have default constructors, right? Maybe. Okay. I am not going to do this. Instead, I am going to the 1, 2, 1, 2, 1, 2. Cool. So here I have my output, and here is where I code. Um, all right, right, right. Message file dot header. Do this. What is this dot pch? I've never seen that file. Dot pch file. Decompile header file. Yeah, yeah, yeah. Just need your compilation process. Okay. But it worked. It worked. So, okay, we have this, and what this will do is that it will create a std queue object for us of type D, and the name will be Q, which will be the symbol different. So, BFQ. Cool. So we have BFQ over here, and we have push operation. When someone tries to push something onto it, it will be a value T, and when someone does that, that is push run, right? Something like that. Oh, it's directly push. Okay. Okay. BFQ, and then we have pop. Pop doesn't take anything. If pop returns something, it's a void pop. Okay, it doesn't return anything. It really calls dot pop front. Okay, it automatically does that. So BFQ dot pop front. Cool. And then we have, okay, so far we have this, and then we add a, we're going to trade. Yeah, okay. So we have this so far, and validate it. So, okay. So let's say I'm inside main.cpp and I'll import, include, we'll just directly get the header file, so which is, what is it called? bf2, 2.h, hash include, and we create a bfq object, bfq, of type int, temp temp dot push one temp dot pop, and this should work. Maybe. Okay. Use of a declare identifier BFQ and BFQ because this isn't available outside, so I need to make it. Don't need to make it static. I think this will work, but I don't think it's a good way. I think I should. Oh, fuck off. Sorry, I'm really sorry. I should never say that. But okay. So temporarily this should work. What? Use the fund declare identifier BFQ. BFQ dot push. BFQ dot pop front. BFQ. 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 Sorry. BFQ. Yeah, good. Yeah. Let's move this. Oh yeah, yeah, yeah. Right, right, right. Because by default stuff inside this is that way. This was correct. By default, that move is correct. User fund declare identifier. Yeah, how about we just do this? So we have std q d df and we just don't have anything over here. November named pop front is std q and yeah, fine. I'll just remove that. Do. Boom, boom. Easy. Yeah, okay, so it worked. What am I doing? Yes. If I do temp that, so, do we have a pop? So, uh, how do I see the topmost value without popping anything? Is there a top? Okay, there should be a size, right? Okay, cool. So void is size, not void size, different size. Return view dot size. So that's cool. This is your temp dot size. Okay, so this should work. Wait, what am I doing? Okay, 1 and 0. Yep, cool. So okay, it's working. Um, so now we have to just keep on adding stuff to it and hope that. So, okay, so this is the basic idea that we have for BFQ. So let me just show you what is a. Okay, let's just first discuss like what I want to do this. So yeah, okay. Now this looks weird. Okay. So what I want with this is that I want to create my own queue, which will have like atomics and stuff, and it will be SPSC, single producer, single consumer, and it should be blazingly fast. That's what I want from this project. So there is one implementation that is quite simple for me to understand. So okay, so if I go to SPSC boost, SPSCQ boost, there is an implementation. Boost lock free SPCQ. Boost SPC lock. What was it? Boost lock SPSQ. So this is the stuff where I can see there is implementation. Okay, maybe it will be inside. Wait, what is this? Um, okay, SPCQ. Then we have some stuff over here. I don't understand what the. Okay. SPCQ void. It's doing a bunch of things. I don't understand what it is. SPCQ size, navigator, no. This is just like different types to initialize, different ways to initialize it. Equality operator, R value. What is this called? Ah, I forgot. Copy constructor. This is copy assignment. This is copy constructor. Yeah. Okay. Oh, we have them deleted. Why is that? Function objective. Where is the implementation? What? User the ring buffer. Oh, they use ring buffer. Okay, cool. Well, we are going to use that too, but for now we just want to make something simpler. Maybe I'll make an array and maybe I'll use vector. You know, never know. I'll use a vector maybe. So I just want. Okay. So okay, we are not able to find it, but I found the next thing that we have. So this is another library, another repo, the rig top SPSCQ. And what this person has done is that they have implemented an SPSC, and it's quite simple to understand. You know, the boost and folly they might have something very complex. And SPSC and his library is quite fast. You know, I think there is a benchmark somewhere down there. Yeah, okay. So if you look at this SPSCQ, the throughput is higher, latency is also better, and folly and boost we have over here. They're okay, they're good, but this is just destroying them. And we are going to test that against these three. We are going to test RQ against these three. But okay, so for now, I need to understand. So what I'm going to do is that, see, they've already given what all stuff do we have. So that this is what everything that I'm going to implement, but I'm just going to make it faster, blazingly faster. This is a old repo. Like there are not a lot of there is nothing happening. Basically, the last thing was 3 years ago. Remove redundant padding. Sorry, and yeah, let's look at the implementation. This is yeah, Eric Richthofen. Oh, Eric Richthofen. It's his name. It's his surname. Okay, cool. So we what has he done? If not, okay, I shouldn't be saying. So yeah, capacity allocator. Oh, this is what it is called. I forgot. Um, the class initialization or something. I don't quite remember, but it's just used for initialization. Yeah, nothing much. Needs one stack element, create overflow size tree, and this and that. Boring, boring. This is destructive over here. Blah 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 blah. Okay, nobody cares. I do, but I just want to say that. So yeah, we have in place. Well, let's not look at a place for now. We'll look at it afterwards. In place just means that we are constructing the object in that address itself. That's what it means, right? Nothing much over there. Not long. It's load. Read IDX cache and whatever. And yeah, it's a quite simple implementation. Maybe it will take a single video to understand. But for now, we are not over here. We are just going to look at this, which is the stuff that they have given us. So SPCQ can take is initialized using what kind of capacity do you want to start it with? There's an in place. You have to give it R value reference. Stage. Okay. Enqueue an atom using in place construction. Block if queue is full. Try and place, goal, push. Yeah, returns to console. That's what it will do. There's a push. There's a pop. Push, pop. Pop doesn't return anything. Try push. Try push. Try push. Okay, okay. Using move construction. Yeah. Return a pointer to the front of the queue. Goal, pop. Size T, boolean T, return true if queue is currently empty. Only a single writer thread can perform NQ operation, and only a single reader thread can perform DQ operation. Any other usage is invalid. Huge speed support. Yeah, yeah. Okay, okay. So that's what we have over here. So there is testing stuff over here. This basically test. Is this what I wanted? Yep, I think this is what I wanted. Between this, at the top is this, space Q, and then we do the stuff over here. Yeah, cool. So that's what we are going to do too. So, okay. So they have given like how to test this. So that's what I'm going to do right now. So I'm going to clone this, git clone this, and then they have given like how to test this, right? They gave it somewhere over here. No? Yeah, fine. We'll just run it. This is one. So we go over here, space here, SRC, apply, maybe SPC. Um, Benchmark, is that what I want to run? Why isn't this in dark mode? What? Why not? Why doesn't it work? Okay, fine. Yeah. Benchmark. Is this what I want to run? This test. Let's run benchmark first. Like top spcq.h, and it doesn't understand what we are trying to do. Fine. So we'll try to do all of this. I'll just move the file from what is it? Here. This again. Where, where, yeah, okay. At the top, to the current directory. Now we should use quotes. Oh yeah, yeah. It's a simple stuff now, right? So to user file declare CPU set D. From what I've read online, see struct.h CPU set is a struct that contains a bit mask where each bit represents a CPU that can be used for the thread process. This is how it is defined. This is CPU. Yes, it's an array based form for the possibility that you have more CPUs in the CPU set size is the living base, and you can look at that whatever. So CPU set T is something present on Linux systems. So I don't think Unix systems have these. Where is CPU set used? CPU set D. Yeah, only at two places, right? Hmm. Hmm. What is CPU set D? The guy said about CPU set D. Yeah, it's a simple this. When it comes to this sort of stuff, I'm struggling to compile a dynamic model on macros and boil it down to what is going on here. Returns is its affinity bound to a single core or else minus one with affinity single seven single seven. When combining, I get this errors, CPU settings and fine. Okay, and regards the complete computer. You Googling put on the right track, schedule capability, and the CPU structure that it uses are link specific and are not available on the platform. Microsoft critical seems to be missing them. However, there are alternatives. I found a blog from someone quoting code OSX that found an alternative to use system CPU by name. Okay, the code in that. Okay. So if this is not working, let's first try test. Oh yeah, also change this test. Please don't. Okay, the top. Oh, it worked. And what do we have? Per liter per iteration. Okay, so 130 nanoseconds per iteration. That's cool. What even is the test doing? It's a 200 line stuff. Create of capacities. One capacity less than zero. Assert. Case false. Q. 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 Mm, mm. Yeah, this is just testing if it works or not. Benchmark isn't working. Let's read the article. Okay. And there's nothing over here. Okay, okay. Take two documents. The code number that the thread should be bound to is for the sequence of parameters. The sequence set is called the code number of the structure. Okay, it basically doesn't work, so I need to run this on something else. Something else. I do have an Arch machine, like an x86 Arch machine. Of course, right? Well, can we let's try to do some jugaad, as we call it. So there is a CPU set the structure, right? So what does it look like? Maybe we can hack it to some. So, okay. So the only problem is this, that it doesn't list how much CPU settings. Other than that, there's nothing, right? But, eh, eh, but, hmm, hmm, oh, okay. This plus is not. And this, you CPU setting. Oh, there's, no, there is a sizer. No. Yeah, I understand that. Okay. So CPU set T structure isn't available. Researcher represents a set of CPUs. CPU sets are used by Infinity and Semester. This, oh, it's part of the Linux programming interface. Let's go. It's time to read the book again. Easy. Where do I have the book? Okay. I'm just going to let this for a minute. You can look at my face. Don't know. Till then, so downloads, no, downloads, no. Um, uh, no, what? Yep, found it. And sorry, I'm really sorry. And we have the book ready. No, no, recording. I'm audible. Recording. Cool. So 38 minutes in. So okay. So let's see what we found. Okay, now start this. CPU set. Oh, what is this black line? Crazy. Are the pixels dying or something? It doesn't extend. Yeah, let's start. The CPU information to be assigned to the processor is specified in the CPU set T structure functioned by conducted by a set. Although the CPU set T data type is implemented as a button mask, we should treat it as a weak structure. All manipulation of the structure should be done using macros, CPU 0, CPU set, CPU CR, CNR. Okay, but there is the implementation of CPU set. Let us look at how is it constructed. And I see it. What? Where is the implementation? Brothers, I want to replicate it, brothers. I am so okay, bro. I understand this. So the only thing that they want from CPU set. is, oh, sorry, you guys saw it. My bad. So the only thing that you want to see is the size of series. So what is the size? Blah. Hmm. 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 Yeah, not just size, it's taking this. Yeah, okay. I think I have to run this on a different machine. Just give me a minute. I can't pause the video, so you have to, like, there is no option for pausing because I set this OBS studio to, okay. So if you look over here, I just can't pause it. Okay. I cannot pause my videos at all. It's because I've set it to like custom FFmpeg, something like that. Because of it, I'm able to use better quality, but I can't pause the video. So you have to hang on. Just give me a minute. Oh my God, there's a lot of dust on it. Okay, I need to clean it. Shit. I'm so sorry. I shouldn't have said that. Look at this. Look at this beauty. This was my earlier laptop for a while. There's still a lot of dust on it. Look at this. Okay, let me boot it on. I think it has 4 gigs of RAM, and it doesn't have battery. But we gotta do what we gotta do. I like if it was the like if I would have been doing this before maybe like 5 months ago, I would have done it on an AWS instance, but my 1 year free trial has expired. So I don't want to risk anything and I don't want to be charged. So I'm just dealing with it and boot a new machine up and test it. Ah, maybe I should run it inside a gaming emulation. Yep. Oh wait, that's what I should do. Okay. Run a CVP code in x86. Oh, oof, Linux emulation. But it doesn't matter what the emulation is. I want a Linux system itself, and I don't have a VMware. Like I used to have. Okay, come on, boot up. What? Eh, there is no Linux. Why don't I see it in boot device options? So if I do this, this is name. Okay. So we do see Debian at the bottom, and if I press enter, sorry, try. Okay, why isn't this working? This was working for a long time. Okay, okay, it worked. Okay, my bad. What is this? Uh, it's, it's okay. It's okay. So it's booting up. Let's go. Oh my god, I don't think I remember the username and password. What was it? What was it? Ah, let's go. We are in. Okay. So, what was the? Okay, I forgot again. It's okay. Um, what was the stuff that I config on? There's a specific word for it. Not this. No, no. It starts with W. Is this MMCNI? Is that what I want? No. There's a really cool thing that opens up. Okay, I'm just going to not waste a lot of time. I have I have a machine that works purely on terminal and want to connect it to use to have a package for it. Don't remember the name. Starts with W. C. PLI. WPS applicant. IWCTL, MCLI, and all of these. Yeah, IWCTL. Principal application. M3. I don't think it's an M2. Oh, it was an M2. I'm so sorry. Good. Okay, it was an M2. Oh, I'm so sorry. Okay, yeah, it's visible for you guys. Okay, so am I connected? Wait, that's my phone. Do I have connection with you? Two devices, and yep, I do have a connection with you. So, okay. So I'll just git clone the repo in my machine. Yeah, okay. It's basically just yes, github.com, dot, let's see, let's see, dot git. Okay, so we have it's basically letters, and I don't think I have GCC inside this. Oh, I do. Okay, of course I will. It's an automation. I would have installed it previously. So CD why into also so CD service CD source move this with dot so with dot with your yes inside benchmark. By the way, new vim on this looks so sick. Let me just show you. There's a scale. Look at this. I'm going to somehow set up show you guys what I'm doing. Okay, it's not going to work. Uh, but I'll still try, you know. Yeah, okay. So I have this, and so this should work. Okay, so G plus plus SPCQ benchmark.cpp, and does it compile? Use of stood hardware destructive inference size. Oh, it's a warning, right? Yeah, okay, nobody cares. Just run it. 16,000 operations per millisecond and 392 nanosecond RTT. What does RTT mean? We don't know. Just 13,000. Just think of it. Huh, I don't think you guys would have seen this, what I did. Just show you. So basically, I just run the benchmark and you have these values. Oh, you have these values, right? SBCQ, that's really cool. On this machine, this bad boy of 4 GB RAM and some i3 or what kind of chip does it have? I think it's i3. No, not even i3. I think it's lower than that. But it has 3x so that's good. So this bad boy gave us a score of 16,663. We'll run it again. Yep, it's stuck on 13,000. Again, 17,000. Okay, plus this. Okay, so I think this is the for the video. What do we do? We have seen how the implementation, what all do we need to implement. So what I will do is that I'll go inside this benchmark test. So so this is kind of like a template for us. We are going to implement all of these, and we are going to use the benchmarking library. Sorry, not this one. This is it. And we are going to use the benchmarks.cpu file at our advantage, so we don't have to write a benchmark. Okay, I'm so sorry it's ripped off, but gotta do what we gotta do, man. Sorry. So we are just going to do this. We are going to just going to change the name over here, and that's it. That's what we are going to do, and then it will just do some stuff for us. So okay, if we are inside benchmark, if you see SPCQ, look, it's just 4 times. Once in the header, once in the output, once over here, and second time over here. Oh, not very serious. Okay, yeah, and nobody cares. I'm just going to implement that template that we find over here, and this is the benchmark that we are going to run, and it will give us a value. And yep, that is it. Thanks for watching this video. I'm Prashant, and I am an engineer for fun. Bye.